before Miss proceed with chapter 11, there are few things in chemistry that I need to recap with all of you first. Okay, so kita semua tahu we have an atom. Okay, for example, atom yang you guys belajar like in the periodic table, right? So we will have the atom. Oh, okay lah, not bad lah, still can see. Okay, so atom. In atom, we will have nucleus, am I right? So we'll have nucleus and also we will have electron shell. So electrons lah. So meaning you will have electrons. Okay, so this is your electrons. Okay, read also can lah. Electrons. And this is your nucleus. Okay, Miss nak tanya, dalam nucleus akan ada apa? Proton and? Very good. We will have proton plus neutron. Okay, so far so good everyone? Okay, good. Okay, then I try to use this color. This color okay ah? Okay, so we will have atom. So in periodic table, Hana boleh nampak ke tak? Kau tak main duduk depan je? Huh? Boleh. Okay, so in periodic table, we will know we will have these two number. For example, A and Z. And A ni number of what? Nuclear number. Okay, nuclear number will consist of proton number plus neutron number. Okay, boleh? Okay, what about here? Very good. This is proton number. Okay, this is very important now. We will use in physics. Okay, so for neutral atom, pernah dengar tak neutral atom? Neutral atom is whatever you're going to learn in physics. In chemistry, dia ada juga not neutral atom. Okay, so for neutral atom, it is very important you guys know that proton number is the same as electron number. Okay, kan? Proton number sama dengan electron number. This is for neutral atom only. For neutral atom only. Okay, so far so good? Okay, I would love if you guys could copy this. Okay, let's say, how do I, it's okay, you guys copy first lah. Okay, how do I find number of neutron only? Macam mana Miss nak cari number of neutron? Apa tolak apa? Very good. Number of neutron will be nuclear number minus proton number. So this is for how you find your number of neutron. Okay, so this is the basic things that I hope you guys can understand lah. Okay, this one finish? Okay. Online kids, are you guys okay? Okay, Miss.
Okay, Miss.
Okay, baiklah.
Okay, Miss.
Okay, may I proceed? Belum lagi. Okay, everyone finish? Alif dah? Alif nampak tak? Belum lagi. Alif tak ambil duduk depan. Mana duduk depan, Miss? Hidayah dengan Alif duduk sini. You guys better be happy Miss nak habis syllabus. Just now Miss habis syllabus dalam satu kelas tu. You're very murung. I think they still do physics good. Okay, dan Alif malah duduk depan. Okay, Miss proceed Okay, so now welcome to last chapter for this semester and for your matriculation syllabus. physics. Okay, we will learn about nuclear and particle physics. So the first part is binding energy and also mass defect. So before I talk about binding energy, Miss akan discuss dulu pasal mass defect. So the first learning outcome is define and use mass defect. Okay, so what is mass defect? Okay, I'll read first, then we will go through the definition together. So it is the difference between the sum of the masses of individual nucleons that form an atomic nucleus and the mass of the nucleus. Meaning, okay, so you know you have nucleus. So this is, for example, this is my nucleus. Okay lah, for example, in my nucleus, I have 3 proton and 2 nucleon. Okay, boleh? Not nucleon, sorry, neutron. Susah sebut. Okay, for example, I have 3 proton and 2 neutron. Okay, so this is what we call mass of nucleus. But this mass of nucleus will not be the same as individual masses of this proton and neutrons. Ada 3 proton, betul tak? So this is proton, proton and proton, and this is neutron and neutron. So the mass here will not be the same. Why? Because there is mass defect. Senang cerita, let's say this is nucleus, korang anggap. So this is nucleus, ada 3 protons and 2 neutron, right? But now, actually, if I separate this, if me separatekan dia pun, supposedly mass dia sama je lah kan, because gabungan dia dapat sama sepatutnya. But it will not be the same because due to the mass defect. So meaning, when you separate it, dia punya mass itu lebih banyak daripada bila korang jadikan dia as nucleus, gabungkan dia. The individual masses will be greater than the combination, the nucleus. Okay, why? It's due to the mass defect. But dia punya mass tu tak beza mana pun. It's only around 0.0221. So it's very, very small. The difference is very small. So the first part that you guys need to understand is the mass of nucleus is not the same as the individual masses. Boleh? The combination of the individual masses. Okay. Kesan blog online. Okay, can. So literally, if you want to get only okay, so inilah dia punya ni, mass of nucleus tak sama dengan individu, combination of individual masses. Where's my eraser? Combination of individual masses. Okay, and dia yang akan lead to the mass defect. So literally your mass defect, okay, this is symbol for your mass defect. So your mass defect will be the combination of individual masses ini tolak dengan mass of nucleus. So combination of individual masses tolak dengan mass of nucleus. But how are we going to find the combination of individual masses? Okay, now I'm going to teach you. Okay, listen first, later Miss bagi masa Salim boleh? So, how I'm going to find the combination of individual masses? So, look here, we have how many proton number here? 3, am I right? So, we must consider the proton number. Sorry, not proton, betul lah proton number. Number of protons dia kat sini ada 3. And neutron number ada berapa? 2. And we must consider mass of proton dan juga mass of neutron. So therefore, mass defect is proton number of protons darab dengan mass of proton tambah dengan number of neutron darab dengan mass of neutron minus mass of nucleus. So you will get mass defect. So remember, combination of individual masses ini dia consists of, for example here kita tahu kita kena ambil number of proton darab dengan mass of proton tambah dengan number of neutron darab dengan mass of neutron. So for example here you have 3 number of proton and darablah dengan mass of proton dia berapa, and we have 2 number of neutron darablah dengan mass of neutron dia berapa, and tolak dengan mass nucleus. Then only you can get mass defect. Okay, so itu adalah for all atoms in the periodic table. Tetapi for hydrogen is a bit different. Hydrogen tak ada apa? Tak ada neutron. Neutron, right? Tak ada neutron. Because hydrogen tak ada neutron, dia punya formula is a bit different. This is only for hydrogen. Kita akan ambil number of proton, darab dengan mass of hydrogen, tambah dengan number of neutron, darab dengan mass of neutron minus mass of atom. So the atom is for hydrogen. So this is for hydrogen only. Okay, ini adalah untuk hydrogen only. And this is for all other atoms. Usually untuk hydrogen dia tak tanya. Dia selalu akan tanya untuk other atoms. Boleh? Ya. Yeah. Dia try ni nukleon. So, apa? Dia tak ada apa? Neutron. Okay, wait, let me check Sorry, I'm not good with chemistry tau. So hydrogen tak ada nukleon ke, tak silap miss? Hydrogen do not have neutron. Hydrogen can have no neutron because it only has one proton. Dia tak ada neutron, correct? No neutron. Tak apa, that's just the formula. If not, jadi kosong juga. Oh, okay. Okay, this is just the formula. Kalau dia tak ada neutron, dia akan jadi kosong juga. Okay, boleh? Itulah miss macam pening nanti. Okay. Can? Okay. Alright, so what is the unit for mass defect korang rasa? Mass. What is the unit for mass? kg. Okay, but we got another mass. Okay, unit dia adalah kg. So, or another unit is U. Okay, U. Okay, paling penting korang kena tahu how to convert. Allahu Akbar. Okay, itu unit unit kg or U. It's okay, I rewrite again. Mengarut lah dia. Okay, wait, don't salin yet, Miss will give time. Unit dia adalah kg or U. And you need to know how to convert the unit. So, how do you convert the unit? Miss will write here. 1 U will be the same. Tak sesuai ni tempat ni. Sorry, you guys should know. Okay, 1 U sama dengan 1.66 times 10 to power of negative 27 kg. So this is how you convert the unit. Okay, boleh ingat 1 U bersamaan dengan 1.66 times 10 to power of negative 27 kg. Okay, now you may copy. Laju. So remember, MP is mass of proton. MH is mass of hydrogen. M nucleus is mass of nucleus. M atom, mass of atom. Alif nampak ke Alif? Kau awak masuk Google Meet dah. Kan Miss kata main duduk depan Miss. Tak mau dengar. Ni semua salah Hidayat. Mass of neutron. Z adalah number of protons. N is number of neutrons. Okay, online kids, are you guys okay so far?
Okay, Miss.
Okay, Miss. Okay, that's good. Udah finish? Okay, good. Wait. Okay, once you guys are done, do let me know, yeah. Actually, for my handout, right, just sign in wherever you guys want and what you guys faham. If you guys want to copy the exact one, also can. Dia tak present lah. Wait ah. Wait, I keep present. Sinja dan Kalai, Mawadah dengan Hanada. Sikit, okay. Sharoni dan okay. Fatin, Santi, Izzati. Kok suara dia? Yoel dengan Isra dan okay, Hidayah dengan Alif. Mawadah? Okay, good. Okay, so let's proceed. So Miss rasa kalau kawan korang dah siap, korang pun dah siap ke online students. Okay, so the next one, okay, before Miss proceed, Miss nak tanya satu benda. Okay, let's say I have mass of atom. Okay, contohnya Miss akan ada mass of atom. So, macam mana Miss nak cari mass of nucleus sahaja? How? What should I do? Kita akan buat apa? I have the total mass, the atom punya mass, right? So, Miss nak cari mass of nucleus dia. What should I do? Mass of atoms tolak dengan? Okay, now I want only nucleus punya mass. Now I have the whole mass. Okay, I have the whole mass of atom. Tolak dengan electrons. So tolak dengan Z. Z is number of electrons because number of electrons is the same as number of proton. Darab dengan mass of electron. Sebab apa? Sebab sekarang Miss ada the whole mass ni. Miss ada the whole mass of atom. Tapi Miss nak apa? Miss cuma nak yang mass of nucleus sahaja. So if Miss cuma nak mass of nucleus sahaja, Miss kena get rid of apa? Get rid of electrons. Boleh? So bila Miss nak kena get rid of electrons tu, so Miss tolak je lah number of electrons darab dengan mass of electrons. So this is your number of electrons. Tambah sikit nota ni boleh? Okay, this looks simple, but when you guys do the question, you guys will feel apa benda ni? It's always like that. Okay, done? Okay, done. Okay, only we proceed to the next learning outcome. So the next learning outcome is define. Define and use binding energy. So what is binding energy? So first of all, you need to know binding energy will work both ways. Dia akan work both ways, as in dia akan separate ataupun dia akan combine or bind it lah, kita kata. Okay, meaning, so what is binding energy? Let's say you have a nucleus, okay? So you need binding energy because binding energy is the energy required to separate a nucleus into its individual protons and neutrons. Okay, maksudnya, okay, ni nucleus Miss tambah, Miss ada binding energy kan? So bila Miss ada binding energy, baru dia boleh separate kepada individual protons dan juga neutrons dia. So from this one, dia akan ada smaller mass. Bila dia together, dia combine, dia ada smaller mass. Tapi bila Miss dah pisahkan dia menggunakan binding energy, energy yang diperlukan itu, gabungan ini, gabungan individual masses ini adalah greater. Okay, boleh faham ke ni? So this is my analogy. I suka pakai tangan pula tiba-tiba. Kesian students. Okay, so first of all, dia akan ada nucleus. So gabungan lah, mereka gabung. So bila mereka dah gabung, mereka akan jadi individual dan individual. So remember, bila dia separate, dia punya mass adalah greater. Okay, highlight. Separated much more greater when it's combined. So the formula is, I try to use black pen pula lah. Okay, binding energy EB equals to the mass defect darab dengan speed of light squared. Okay, this is the most important. Your mass defect must be in kg. Wajib in kg. And of course, energy unit dia apa guys? Joule. Unit is joule. Okay, your unit is joule. Okay, so where delta M is mass defect, and then C is speed of flight. Speed of flight, the value is constant, which is 3 times 10 to the power of 8 meter per second. And also, EB is binding energy. Okay, can? I think next time Miss kena kumpul duit lah beli iPad. Be much more easier. Okay, boleh Miss proceed? Okay, so that is binding energy. The third part, we will look at determine binding energy per nucleon. So meaning per nucleon number je lah. So this is binding energy per nucleon. As we know, we will have atom, and then for example, A and Z. So you know this is nucleon number. So it's binding energy per nucleon tambah je nucleon number. Okay. Okay, so for nucleon number, we use A. Okay, we standardize with all the physics punya name. So A is number of nucleon in nucleus. A is number of nucleon in nucleus. In a nucleus. So beside nuclear number, dia boleh jadi juga mass number. So it could be also per mass number. Mass number juga sama juga dengan atomic mass. And the unit, okay, this unit will be a bit different. Unit dia adalah joule per nucleon, or it could be mega electron volt. So meaning 1 mega electron volt equals to 1.6 times 10 to the power of negative 13 joule. Okay, this is the conversion, unit conversion. Do you guys have any question? Okay, if you guys are done, you may try with example 1 and example 2. But remember, for example 1 and example 2, when we are calculating using U, okay, U, please make sure awak ambil whole DP in calculation. Ni penting Miss cakap je, yang ni tak apa, ni nanti korang akan tengok sendiri je. In this chapter, tolong buat nota ni sikit In this chapter, take whole decimal place. In calculation. Remember, don't round off. Jangan round off gatal-gatal tangan. Okay, especially when you are calculating your U. So whatever in your calculators, tak kisahlah 0.28, panjangkan, take everything. Okay, because this is what we calling mass defect. So mass defect mesti cakap, dia punya nilai beza tak? Ketara ke tak? Tak, sangat sikit, right? So bila sangat sikit, we have to take everything in calculator. Okay, try to do example 1. Okay, Dad? Oh, you want to go this one with me? Example 2, try by yourself. Why? We vote. Nak buat dengan Miss ke nak buat sendiri dulu? Miss. Oh, okay Miss. Baiklah duduk balik. Baru nak jalan. Okay. Okay, we do together If ada orang yang nak try sendiri, you may go ahead. If not, we do it together. Okay, this is very, very important. I'm going to teach you how we're going to tackle this kind of questions step by step. Okay, the first part, highlight lah. Calculate the binding energy of an aluminium nucleus. So our atom is aluminium. So we know aluminium 2713 Al. Okay, my question, 27 is what? What number? Nucleon number. Okay, 13? Proton number. Very good. Okay, how can I get neutron number? Okay, this one I do step by step. Nanti korang kalau nak tulis, tak nak tulis tak apa. Neutron number is nucleon number minus proton number. Very good. So you will get your neutron number for 14. Settle. So this is the first step. Okay, okay. Look at the question properly. Dia nak dalam mega electron volt. Highlight and circle mega electron volt. So given the mass of neutron, you already have mass of proton given, mass of electron, speed of light also given, and atomic mass of aluminium is given. So atomic mass, please use what is given Jangan pakai 27, pakai yang diberi. If you look, all the masses given is in U. Correct? Okay, now binding energy. What is the formula for binding energy? MC squared. Okay, so now we already know our speed of light. Speed of light is constant. Okay, how do we find our mass defect? Macam mana kita nak cari mass defect? What is the formula for mass defect? Number of proton darab dengan mass of proton tambah dengan number of neutron darab dengan mass of neutron tolak dengan mass of nucleus. Mass of, okay, number of proton dah tahu ke belum? Look here, we already know, correct? Mass of proton given. Number of neutron kita dah cari ke belum? Dah, very good. Mass of neutron given, right? What about mass of nucleus? Diberi ke tidak? Tak. Macam mana nak cari mass of nucleus? Okay, this is your second step. Okay, same color, I don't want. So, how do you find mass of nucleus? Very good. So, mass of atom tolak dengan number of electron darab dengan mass of electron. So, mass of your atom berapa? Given 26 point. Okay, take everything. Don't round off. 26.98154. Okay, Miss nak tanya, number of electron? 13. Why? Sebab number of electron sama dengan number of proton. Mass of electron? 5.48 times 10 to power of negative 4. Kenapa it is given? Okay, I try to highlight using this color. Okay, tak apa, Miss yang geli. Okay, now we already have our mass of nucleus already. So mass of nucleus, okay, try to put in calculator. How much do you get? Remember to take everything. Check if you get the same as me. 26.974416 U. Do you guys get the same? Oh, very good. Ambil semua tau. Okay, now only we can look for our mass defect. So mass defect, okay, number of proton is 13. Mass of proton 1.007276. Okay, number of neutron 14. Mass of neutron 1.008664. Mass of nucleus, we already calculated 26.974416. Betul tak? U. So this is your third step. So you will get your mass defect 0.241468 U. Am I done? Kenapa? Dia nak dalam mega electron volt. Betul tak? And we know 1U bersamaan dengan 1.66 times 10 to power of negative 27 kg. So therefore, kalau 0.24146 AU ni macam mana? Oh kita, no, sorry. Miss kena, apa tu lah? Miss buat drama pula. No, we have to change it to what first? kg. Ha, betul. Sorry Okay. Kita bukan kita tukar kepada kg dahulu. So how can I get in kg? Miss akan bahagi ke darab dia? Darab. Sebab 1U equals to 1.66 times 10 to power of negative 27. So berapa korang dapat? Okay, for kg you guys may round off. Untuk kg dah boleh start round off. EU boleh round off ke tidak? Tak. Hana mari depan. Ha, Miss panggil dah. Kalau Miss tahu buat kelas kat lab. Okay, so we already get our mass defect. So when we already get our mass defect, this is our fifth step. Step yang ke-5. Masukkan dalam formula binding energy. So binding energy mass dia akan jadi 4.01 times 10 to power of negative 28 and our C berapa? 3 times 10 to power of 8 squared. So you will get your binding energy 3.608 times 10 to power of negative 11 joule. Okay, now am I done? What should I do? Change to mega electron volt. And you must know 1 mega electron volt equals to 1.6 times 10 to power of negative 13 joule. So daripada joule nak dapat mega electron volt, Miss kena bahagi ke darab? Bahagi, very good. So kita kena bahagi. So bila kita bahagi, kita akan dapat our final answer 225.47 mega electron volt. Okay kan? Oops. No, do you get the same answer? Okay, very good. Siapa yang dapat the same answer, you may proceed with example 2. Example 2, you already get the answer as well? Okay, can I check? Joule per nucleon. Mine I got 1.038. Maybe I don't know because I took lots of decimal places, so it's okay. Okay, I'll give you 1 minute untuk try. Sejuk ke? Okay, online kids, are you guys okay? If okay, tekan nombor 1 di chat box. Kalau tak okay, tekan nombor 2. Okay, very good. Sinjay, okay? Alright, okay, good. Okay lah, tak bad lah. Boleh lah. Boleh terlindung dengan komputer. Okay, good news. Next week we will be having UPS3. Then we are done with PB. Then I give you final mark for PB. Okay, first mark over 65 because when I mark your lab report, okay, like all got 40, 40, right? Hopefully, if the moderator does not change the mark, because there will be two lecturers that mark your paper, kan? Okay, should we proceed to example 2 ke belum lagi? Belum, okay, buat dulu example 1. Okay, yang lain try buat example 2 ya. I'm so tired today. Okay, done? Semua orang dah ke? Belum? Example 1. Sinja not yet? Example 1. Okay, no, I'm meaning example 1, is everyone done with it? Yes, itu yang bisa dengar. Okay, so now is example 2. Sekejap, online kids dah habis ke example 1?
Dah. Dah, Miss.
Buat example 2 ya. Okay, Miss akan explain while you guys do it. Sinja almost ke? Shall I finish? What's the answer you get? 3-5. Okay, can. Alifin dah ke? Belum? Start ke? Tak kan? Hana dengan Mawada dah ke? 2. Oh, tak buat lagi? Tengah buat. Sharini, darling. Example 2 finish? Fatih Adriana dengan Santi? Still doing it. You all dengan Yusra? Izzati? Tengah, okay. It's okay, we do it together lah. Okay, calculate the binding energy per nucleon. Highlight perkataan per nucleon tu please. Very, very important. of a boron nucleus, in joule per nucleon. See, the question minta in joule per nucleon. So jangan bagi dalam mega electron volt. Jangan bagi dalam mega electron volt sebab dia minta joule per nucleon. Okay, so what must you do is, first thing first, look at the atom. So 10, 5 boron. Okay, so 10 ni number of what? Nucleon number. And this one is proton number. So how do we get neutron number? This is the first step. Minus. Very good. Neutron number is 10 minus 5, which you will get 5. Okay, then given mass of neutron, proton, electron, speed of light in vacuum, atomic mass of boron. Okay, we know formula for energy binding per nucleon is over N equals to mass defect times speed of light squared over N, your nucleon number. Okay, may I know, do we have our mass defect? Kita tahu tak mass defect kita? Tak tahu. So mass defect equals to number of proton darab dengan mass of proton plus number of neutron darab dengan mass of neutron minus mass of nucleus. We have everything except for mass of nucleus. So mass of nucleus is your second step. So mass of nucleus will be mass of atom tolak dengan number of electron darab dengan mass of electron. So your mass of atom is 10.01294 and your number of electron is the same as number of proton, which is 5, and mass of electron is 5.48 times 10 to power of negative 4. Ini keluar. Sorry. Times 10 to power of negative 4. So you will get your mass of nucleus. Is everyone get the same as me? 10.0102 U? Correct, right? Remember, take everything. So then, we know number of proton is 5. Mass of proton is 1.007276. Number of neutron is 5. Mass of neutron is 1008664. And mass of nucleus is minus 10.0102. So your mass defect will be 0.0695 U. Am I right? Is everyone get the same? Okay, from mass defect, we need to convert U to kg. So 0.0695 times 1.66 times 10 to power of negative 27, which you will get 1.1537 times 10 to power of negative 28 kg. Your answer will be slightly different because this one I took like 4 decimal place. Okay, so dia boleh jadi kurang lagi, so you don't have to worry. So this is the third step. Okay, so the fourth step is you must convert it from U to kg. And the fifth step adalah masukkan dalam formula. So binding energy per nucleon will be your mass defect 1.1537 times 10 to power of negative 28 darab dengan speed of light squared 3 times 10 to power of 8 squared bahagi dengan number of nucleon. Nucleon number kita berapa? 10. Then you will get binding energy per nucleon number adalah 1.038, or will be slightly different your answer from me because you tengok berapa decimal place you ambil dekat kg dia. Negative 12 joule per nucleon. Okay, boleh? Yes? Oh, sorry. It was supposed to be A. We stick to A. Actually, you can write A or N. Actually, no problem. But international physics we use A. In chemistry we use N, right? But for physics we use A. But no problem also. N also can, A also can. Chemistry use apa? A, right? So we stick with A lah. we use international punya Alah, sometimes misalkan buat A atau N, you guys just get it lah. Okay, actually it's A. But the notes I give A, right? Or N? A, right? Okay, we use A. Suppose it will be A. Because just now, right, if we learn about atom, right? Kita tahu X, A and Z. So Z is proton number, A is nuclear number. Okay, Fatin dapat jawapan. Okay, I want to ask, siapa yang dapat jawapan tanpa Miss Hajar tadi? Sinjay, okay, very good. Lo got? Oh, very good. Okay, happy. Okay, online kids, are you guys okay?
Okay, Miss.
Okay, baiklah, okay. Okay, may I proceed? OL, okay? Finish? Yusra, habis? Okay, so now let's proceed to the last part of 11.1. Okay, it's about graph. Okay, this learning outcome is sketch and describe graph of binding energy per nucleon against nucleon number. So if you look here, you will have graph binding energy per nucleon and then against mass number. Mass number is nucleon number ataupun kita panggil dia atomic number. Okay. Miss bangun Hydrogen, dia tak ada apa? Neutron, right? Am I right? So, kenapa? Sebab dia ada satu proton sahaja. Correct? So, hydrogen, dia akan ada zero binding energy. Okay? Hydrogen will have zero binding energy because it has only one nucleon. No neutron, right? Okay. The binding energy per nucleon dia akan increases rapidly when you increase your nucleon number. Okay, when you increase your nucleon number, your binding energy per nucleon will increase rapidly. Only for light nuclei. Okay, untuk light nuclei sahaja. And dia akan reach a maximum at iron 56. Okay, I'm so sorry cannot use purple. Okay, we stick to yellow Dia akan increases rapidly for light nuclei until dia sampai maksimum dekat iron. Iron dia adalah 56. So, if you want to know which one is the most stable, yang paling stable adalah iron. Kenapa iron? Iron lah yang paling stable sebab iron 56 kan is the most stable nucleus. Sebab binding energy per nucleon dia about 8.8 mega electron volt ataupun joule per nucleon. Okay, mega electron volt per nucleon, sorry. So, nuclei with nucleon number antara 50 sampai 80, mereka akan ada highest binding energy per nucleon. Okay, they will have highest binding energy per nucleon and they are the most stable. Because dia punya range is between 8.8 until 9 mega electron volt binding energy dia. Tetapi binding energy per nucleon will decreases slowly when your nucleon number is more than 62. Why? Waktu tu your nucleus is less tightly bound. Okay? Dia adalah less tightly bound and dia dah get heavier. Dia dah makin berat dah nucleus awak. Okay, dia dah makin berat. So, bila nuclear number awak lebih daripada 62, awak kena faham nucleus awak ni dah less tightly bound dan nucleus awak ni dah makin berat. So, bila for heavy nuclei around, bila dia punya nuclear number antara 200 sampai 240, mereka akan ada binding energy per nucleon yang smaller range, which is between 7 to 7.5 mega electron volt. And these nuclei are unstable dan mereka adalah radioactive. Boleh? So if you guys look periodic table, korang akan nampak. Kan dia akan makin increase one by one kan. So dekat bila dia 200 to 240, dia akan smaller range dan dia adalah unstable dan dia radioactive. Okay, boleh? You guys have any question? No, okay. If no, I have question for you. Okay, Hana. Nukleus manakah yang paling stabil? Very good, iron 56. Okay, so nuclear number, okay, range nuclear number yang manakah akan membuatkan nukleus itu stabil, Hidayat? nukleus dengan nuclear number berapakah yang akan membuat nukleus itu paling stabil lah, most stable? Very good. Okay, Miss nak tanya, kenapa energy binding per nukleon akan decrease bila awak punya nuclear number more than 62? Kenapa? Bang, and nuclear awak getting heavier. Okay, so Miss nak tanya, kalau awak ada nuclear number around 200, 240, awak punya nukleus itu adalah unstable and radioactive. Okay, very good. Okay, so radioactive